Okay, so we're going to go ahead and start on the back and looking at different ways to determine whether a relation is a function. So go ahead and, like I had already kind of started to do some doodling prior to starting this lesson, so feel free to kind of doodle as we go along. So the first thing that I see is looking at a table. So we're going to specifically be looking at like A and B. Okay, so when I go ahead and I look at my table, all right, so I've got my table. I'll make sure that stands out so I make sure that I can find it, okay? Which we've kind of worked with tables on the first side of this as well, so it's a little bit of review. But what we're going to first do is review the columns. The relation will not be a function if any x value corresponds to more than one different being that key word, guys, different y value. So the relation will not be a function if any x value corresponds to more than one different y value. So when I go and I look, I see, all right, I don't have any repeated x values, so right away, that's good. I know for a fact then that yes, that is a function. All right, this one is a function. In fact, I think I'm even going to write function right next to it. I see no repeated x values, so I know that yes, that's a function. But let's go and let's look at B. So again, I'm going to review the columns. I'm looking down my x column, and I notice, that's interesting. I can see that I have a 3 here that corresponds to a -6. And then I have a 3 here, which corresponds to a 6. So I can't predict it. I now see that my input of 3 has 2 possible outputs. Well, that makes it not a function. So in fact, this one is not a function. This is an example of not a function. So again, same thing. We look at those x values. I can see here that I have duplicated 3's. Now, if these were both -6's or both 6's, it would still be a function because it was corresponding to that same y value. But this time I would have to pick, and I'm not allowed to do that. So I can see that this one is not a function. All right, so the next way that you'll see relations written is what is called my set notation, which is this right here, this set notation, this next box that we're going to look at. All right, so here is my set notation. So what set notation is, you'll notice that it's a parentheses, and then it's got these funky little brackets around it because you're grouping it together. You're putting those ordered pairs in a set, which is why it's called set notation. So set notation says to review each ordered pair. The relation will not be a function if any x coordinate, which is the same as an x value, if any x coordinate correspond to more than one different y coordinate. So notice those definitions are very similar as far as table and that set notation. So I'm going to look again and look at these x coordinates and look to see if I have any repeated x coordinates. All right, so I see I've got a 3, I have a 4, and I have a 2. Well, I have nothing, let's get that to focus, there we go. I have nothing that is repeated, so I know that yes, this one is a function. None of my x values are going to a different y value or a different output. That every single input I put in has its own unique output. It's going to get to focus again. All right, so let's look at this next one. So when I go ahead and I look at this, I see, oh, I do have a duplicated number. I see that in this particular set, I have a 1 and an 8, but over here, I have a 1 and a negative 3. So again, it is not unique because when I put a 1 in to my function machine, sometimes it's going to spit out an 8 and sometimes it's going to spit out a negative 3. So there's no way for me to predict what's going to come out. So again, this one is not an example of a function. All right, so now we've seen two different ways. We've seen table, we've seen set notation. So now what we want to do is we want to look at a graph. All right, so here is my graphing. So what we're going to use is we're going to use that test, that special test that we learned yesterday, which is called, very clever name. We're going to use the vertical line test in order to determine whether or not a graph is a function. So specifically, this relation will not be a function if a vertical line ever passes through more than one point. Okay. So we're going to use that vertical line test, and if that relation ever passes through more than 1 point when I do my vertical line test, then I know that it is not a function. Figured I'd kind of get a little caught up. All right. Okay, so let's go ahead and let's look at our graphs and let's do that lovely vertical line test. Ready? So I have to just draw a vertical line. So I'm going to draw a vertical line right here. I can draw a vertical line right here. I can draw a vertical line right here. I can draw one right here. Is it passing through more than 1 point on my graph? No, it's not. So then that means this is an example of a function. But let's go to this one. Bam, I drew one line and it's already going through more than 1 point. It crosses my graph right here and right here. Where on this one, it only crossed there, it only crossed there, it only crossed there, it only crossed there. So I could again do multiple lines, and I'm going to see that drawing those multiple lines, I'm at some point going to go through more than 1 point. So then that means that no, this one is not a function. So now I have examples of what it looks like on a table when it's a function, when it's in set notation, and when it's a graph. So now we're going to look at the mapping. Okay? So a mapping diagram, or just mapping is what we called it yesterday, is that you have to review the arrows. The relation will not be a function if any x value maps to more than one different y value. So the relation will not be a function if any x value maps to more than one different y value. All right, so we're looking at this x value. If I look at this -4, okay, it goes to 16, doesn't go anywhere else. If I look here at the -2, that goes to 4. All right, didn't go anywhere else. -1 went to 1. 4 went to 16. And that's okay. Some of you might be thinking, wait a minute, it got duplicated. But what was duplicated was just that y, not the x. If I plug in -4, I get 16. If I plug in 4, I get 16. I didn't have two possibilities of what one of these answers would be. So then that means that yes, this is a function. But now let's look at this mapping. Okay, so my 3, I see an arrow goes to 4, and wait a second, I have a 3 going to the 16. So which answer is it going to be? 4 or 16. My 8 goes to my 7, which is fine. But my 3 has 2 possible answers. And we've already said that it cannot do that. It must have its own independent y value, its own unique y value. So this is an example of a function mapping, or a mapping diagram, that is not a function. This relation is not a function. All right, last but not least, looking into finding that domain and range. And we're only going to do a few of these actually today, okay? But we're going to look at these, and it says the domain is the set of all possible, which we know, x values. And the range is that set of all the possible of those y values. Because we had learned that in the front. So basically what we're going to do is we're going to identify the domain and the range of the relations in the table, the set notation, and those graph examples above. So when we go and we look at that, we're going to look at A, and you can see that A is our table. So we're going to go all the way up here to the table. And we see that my set of x values is -1, 0, 1. And my y values are 1, 0, 1. So we know that my x values correspond to my domain, and my y values correspond to my range. So how I'm going to write them down here, when I want to list my domain, I'm going to do that little funky squiggly thing as best you can. And I'm literally going to write those x values. -1, 0, 1. That's my domain. Whereas my range, now remember, the 1 got repeated, so we don't actually have to repeat it. We can just write 1 and we can write 0. If you repeat it, it's not wrong, but you don't need to repeat it since those are the only values that were given. All right, so when we look at B, if you look at table B, you'll see that I have a 3, a 0, and we already see that we've got that 3 repeated. So we have a 3 and a 0. But my y values, or my range, is -6, 1, and 6. So I'm literally going to write those down. So it's a lot of back and forth. So I had 3 and 0. And my range is -6, 1, 6. All right, so same thing. We're going to move to our set notation and look at those and find those domains and range. And remember, the domain is going to be the set of all of those x values. So I'm looking for like these. Here's an x value. Here's that x value. Here's that x value. Whereas here's my y value. Here's my y value. Here's my y value. Those are what I'm looking at. Okay, so my domain for C, set notation C, is actually going to be 3, 4, and 2. And then my range, which is my y values, is going to be 3, -1, 3. All right, and then we're going to look at D. So D is the same way. Now remember, we already know we have that repeated. We already knew that. And then we have that 0. So we have 1 and 0 for my domain. But then my range, I see I have 8, -2, and -3. So D is going to be 1 and 0 for my domain, because those are my x values. And my range is going to be 8, -2, -3. All right, so now the graphs are a little tricky when we go and we talk about as far as range, all right? So when we go ahead and we look at E, we know that this one is a function, and this is actually what's called a parabola. And so a parabola actually is going to go on forever and ever. It kind of makes this U shape, and it goes on forever and ever. So what that means is that my x values really, because it does go on forever and ever and ever and ever and ever and ever, we're not going to draw that far, but we know it basically means that all of my x values are possible, okay? So the domain domain for this particular one is kind of a special one. And in fact, what we call it is called all real numbers is what it's called. So this domain, you would literally write all real numbers. Because we're not going to write them all. We're just saying the domain is all of those x values. So now we have to look at my y values. So if you notice my y values, okay, you can see it's, and I'll try to blow up this graph a little bit. It didn't graph as well as I would have liked, or print as well as I would have liked. But you can see they're kind of stopping right here at this point. Okay, you can see it right here. And then they go upwards, okay? So my y values don't go below this value. So my y values have to be greater than or equal to this value right here, which if we look at, is actually -1. So when I go to write down my range for this one, I get to say that my y values have to be greater than or equal to -1, because it's all those values going up. Because we've got all the real numbers for that x, but all of my y values have to be bigger. They have to be greater than that -1. So that's how we write that. It's greater than or equal to -1. All right, last but not least, f. So this one is similar to what we did with the range, and we've already determined that this relation is not a function. But we're going to do the same thing. Those x values, you can see they stop right there and they go in that direction, okay? So if we look at that value, it's a -1, it's a -2. So my x values have to be greater than or equal to -2. They're not over here on this side. They're only on this side of my graph, and they start at that -2. So my domain gets to be x has to be greater than or equal to -2. But now my y values, just like in my other parabola, my y values, even though you can see the arrows, it's going to go on forever and ever and ever. We're not going to draw that because it would take forever. It would never end. So we can then say that my range for my y values are all real numbers. All right, so if you have time, you can go ahead and do the try it. Basically, you're going to create a mapping diagram and a graph that each represent functions. So just making sure that they are truly a function, using everything that we learned up here at the top as far as how we identify a function. If you want to add some colors around here while you wait, that's totally fine too.